The purpose of this video is to give you another example of synthetic division when you have a coefficient on the divisor and the extra steps we need to take with that. So whenever you're doing synthetic division and you have a coefficient on the divisor, the first thing you need to understand is that when you do the synthetic division, it's going to treat the divisor as if it came from a factor that just has x, no coefficient in front of it. So the very first step we're going to take is we're going to factor whatever that leading coefficient is out of the bottom. So this would be 2 times x minus 3/2. So when I go to set up my synthetic division, I have two options to start. I want to show you the way that I prefer to do it first, and then I'll show you the other way just to show you it comes out the same result. So box, line. So in my synthetic division box, we'll go the number that makes my divisor equal to 0, which would be 3/2. Sorry, I just wrote a negative. That's supposed to be a positive. And then next to that will go the coefficients of my dividend. Bring down the first coefficient, and then do the multiply add thing. So 3/2 times 2 is 3, -7 plus 3 is -4. 3/2 times -4 is -6, 4 plus -6 is -2. 3/2 times -2 is 3. That's a lie, it's -3. -3 plus -3 is -6. And that last number is always my remainder. Now, what we just did is we divided by x minus 3/2 when we did that synthetic division. Now we need to divide by 2. So we're going to take our quotient and divide all those numbers by 2. So that would be 1 and then -4 and a -1. And those are the coefficients of my terms, starting with the power 1 less than x cubed. So x squared x. The -1 is the constant term. The -6, we're going to write over the divisor anyway, so we don't need to divide it by the 2 because it's already going to be over the 2 in my answer, the 2 and the x minus 3/2. So basically, I can go ahead and do synthetic division as normal, but at the end, I need to divide just my quotient piece by the coefficient of that x. Now, let me show you the other way you can do this. Same idea, we're starting with 2 pulled out, so the leading coefficient pulled out of the divisor. But this time, instead of doing the division at the end, I'm going to divide my dividend by 2 first. So that would make my coefficients 1, -7/2, 2, and -3/2. Now, in my box still goes 3/2. I'm going to bring down my 1, and this time do the multiply add. So 3/2 times 1 is 3/2. When you add those together, you get -4/2, which is -2. 3/2 times -2 is -3. When you add those, you get -1. And then 3/2 times -1 is -3/2, and that's going to give you -6/2, which is -3. Right? So the key on this is, notice my coefficients came out correct this time because I did the division at the beginning. So that's going to be 1x squared minus 2x minus 1. But this time my remainder came out the wrong size. That's because when I did this division at the beginning, because it came out as a different size. It didn't come out as the wrong size. It came out as a different size. So that's because when I did this 2 at the beginning, I was actually dividing everything by x minus 3/2. So when I write my remainder, if I do it this way, I would write that remainder over x minus 3/2, not 2x minus 3, because I already got rid of the 2 in the first step. Now I could make that prettier by multiplying the top and bottom of that fraction by 2, which I can do because that's multiplying it by a very special form of 1, and then it looks like the answers that I get the other ways. So whether you do it by dividing the quotient at the end by the coefficient, or dividing and leaving the remainder alone, or adjusting the dividend at the beginning and then fixing the remainder at the end, doesn't matter to me.